All right, guys, welcome to this page of the notes. And what we're going to do now is we're moving on to that third objective that I gave you at the beginning of the notes, using I didn't put the Pythagorean Theorem in there, but using the distance and the midpoint formula. We're going to begin to look at those. But I would be remiss if I started talking about the distance and the midpoint formula without first talking about the Pythagorean Theorem. Now, I know you have seen the Pythagorean Theorem, the distance formula, and the midpoint formula before. I know you have. So hopefully this is a review for almost all of you, which means that I would encourage you, please, work ahead. Try these problems on your own. Just come back and check your answer with me. So here we go. Pythagorean Theorem, I got it right here. Let me go ahead and highlight it for you. I shouldn't need to, though, you guys know. Pythagorean Theorem. Now, a couple of important things about Pythagorean Theorem, because they're worth saying, especially if you're not familiar with the Pythagorean Theorem. It's this. Pythagorean Theorem only works for right triangles, simply meaning one of the angles in the triangle must be 90 degrees. It must be a right angle, 90-degree angle. If it's not, Pythagorean Theorem doesn't work. Pythagorean Theorem doesn't work. Okay, and here's the deal with the Pythagorean Theorem. You have three sides of a triangle, three sides. You have two legs, A and B. Those are going to be the legs or the sides of the triangle that are adjacent. Adjacent simply meaning next to the right angle. There's my right angle. There's my right angle. So that means that the side that is next to that angle is B, and the side that is next to that angle is side A. Those are my legs. They're adjacent to my right angle. So find the right angle. Whatever two sides form that right angle, those are your legs. In the Pythagorean Theorem, the legs are interchangeable. Order does not matter, and it's because of addition. Remember, when you add numbers, order doesn't matter. We call it commutative. The addition is commutative, meaning order doesn't matter. You can add numbers in any order. You will always arrive at the same number. That's why leg A and leg B are interchangeable. It does not matter what order you put them in or how you assign them. You're going to get the same answer. Really important though, C. The hypotenuse will always be the longest side and opposite the right angle. There's my right angle. Which side is opposite or across from the right angle? That will be your hypotenuse, and that must be C. That has to go over here. If you were to put the hypotenuse in one of the positions for where a leg should go, you will not get the right answer. All right, so hypotenuse must go in the correct spot. The legs are interchangeable. That's hopefully more than enough said about the Pythagorean Theorem. Let's go ahead and jump right into these. Here we go. Again, draw pictures. Please, please, please draw pictures. Given a chance, I'm going to draw a picture. I want you to find the length of the hypotenuse. Awesome. Of a right triangle. Fantastic. It's a right triangle. I'm asked to find the hypotenuse. You should immediately be thinking Pythagorean Theorem. Given, right triangle, if the lengths of the legs measure 4 units and 3 units. Draw a right triangle. Boom, boom, boom. There's my right angle. Legs are adjacent. Doesn't matter how you assign the legs. That could be 4, that could be 3. This could be 4, this could be 3. It doesn't matter. The legs are interchangeable. I will go 4, 3. This is the hypotenuse, which in the Pythagorean Theorem will always be equal to side C. Side C. Okay, here we go. I want you to find the hypotenuse. So let's do this. Pythagorean Theorem is a squared plus b squared is equal to c squared. Guys, this is plug and chug. Plug and chug. You plug in what you know and find your answer. If you need to use a calculator, please feel free to use a calculator. Just don't fat finger something. And actually, let me explain that statement. Don't fat finger something on your calculator. And I have grandparents. I love my grandparents dearly. They're fantastic. But have you ever seen an elderly person with a cell phone or something like that where the buttons are really small, right? And they're trying to push the buttons and the dexterity sometimes isn't quite there, and they wind up pushing the wrong button or something like that. I get autocorrect messages from my grandfather or my grandmother all the time. They've fat fingered something on their cell phone and autocorrect gives you this crazy word and you almost can't understand the text message because the words are weird and they didn't read it before they sent it. Anyway, right, that's what I mean by fat finger something. So when I say don't fat finger something on your calculator, right, all I'm saying is just be careful of the buttons you push. Make sure you're pushing the right buttons so you don't fat finger something on your calculator and subtract when you should add or put in a 7 when you wanted to put in a 5, something like that. So this is a plug and chug, plug in what you know, don't fat finger something on your calculator, and easy peasy, should get the right answer. So don't fat finger something on your calculator. Here we go. Again, interchangeable. I could put the 4 here and the 3 here, or switch them. You could put the 3 here and the 4 here. It doesn't matter. So here's what we've got. I have a 4, which will be squared, plus 3, which will be squared, all equal to c squared. I am solving for the hypotenuse. I am solving for c. Well, what is 4 squared? Yep, 4 squared is 16. What is 3 squared? Yep, that's 9. C squared, 16 plus 9, let me come up here. C squared is equal to 25. Equal to 25. Okay, couple of quick things. You should already know this. But just in case you're a little rusty on your algebra, I have a c squared. I didn't ask you to solve for c squared. I want you to solve for c. You need to get rid of the square. How do you get rid of a square? An exponent of 2? You need to take a square root. But remember, algebra is a scale. If I take a square root of one side, what do I have to do to the other side? Algebra says whatever you do to one side, you must do to the other side so that equality is maintained. I must take the square root of the other side. And just a quick note about geometry. Why do I take a square root? Here's the reason why. If I have an x squared and I take a square root, what happens is as long as the index on a radical, the index will always be the number written outside of the radical unless it's a square root. 2 for radicals is implied. So if there's no number written here, you just assume it's a 2. So as long as the index and the power are the same, they cancel each other out, and you're left with the radicand, what's under the square root. So that would be x. Let me show you another one. If I take a cubed root of a y cubed, as long as the index and the power are the same, they cancel each other out, you're left with a y. Keep going. Fourth root of a z to the 4th. As long as the power and the index and the power are the same, they'll cancel each other out and you'd be left with just what's under the radical, left with the radicand, whatever's under the radical. All right, so as long as the index and the power are the same, and if there's nothing written, you assume that it is a 2. Okay, so square root. All right, so I have an index of 2, I have a power of 2. Those cancel each other out, and I'm left with just a c. And again, you shouldn't need a calculator for this. Square root of 25 is 5. So what is the hypotenuse? The hypotenuse is equal to a length of 5. Okay, equal to a length of 5. And actually at this point, now is the perfect time to say it. You need to know the first 10 perfect squares. You should already know the first 10 perfect squares, you should. But if you don't, you need to memorize this list. You need to know this list. 1 times 1 is 1. So 1's a perfect square. 2 times 2 is 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9 is 81. And 10 times 10 is 100. These are my first 10 perfect squares, and here's the reason why. Later on, as we go through this course, we're going to be doing a lot of things with algebra like factoring or taking square roots, taking radicals, things like that. These numbers should jump off the page at you, okay? These first 10. Now, hopefully you know more than the first 10, hopefully, but if not, at least know these first 10 numbers and know them well enough that when you see them, I mean, I use like a red flashing light. Perfect square, right? These are perfect squares. Also, we're going to use these perfect squares to help us simplify radicals, which I'll talk about in just a second. Give me a second. All right, so here we go. We've got our answer. The square root of 25 is 5. My hypotenuse is 5. Let's do another one. I want you to find the length of the base of a right triangle if the length of the hypotenuse is 13 and the length of the other side is 5. Draw yourself a triangle. There's my right angle right there. I'm told the hypotenuse is 13. That is the side opposite the right angle. And then I'm told that the length of a leg is 5 units. Does it matter which one I make 5 units? Nope. Doesn't matter. Legs are interchangeable. We'll call that one 5, and I'll solve for this guy down here. Okay, here we go. Please be very, very careful. It is a squared plus b squared is equal to c. Oh, hold up. My pen went crazy. Still going crazy. Hang on a second. I will get this worked out. Boom. There it is. Okay, c squared. Now, please be very careful. Make sure the 13 goes in the proper spot. This is not a leg. This is hypotenuse. It's got to go over there. So 13 squared is equal to, now, again, the legs interchangeable. You could make 5a or you could make 5b. It doesn't matter. I'll go ahead and put it in here. So that'll be a 5 squared plus b squared. We're going to be solving for b. 5 squared is 25. And 13 squared is 169. Again, that is not one of the ones that I put on the list, but if you know the square root of 13, awesome, good for you, that's fantastic. Knowing 11, 12, 13, probably even through 15 is great, but you will have a calculator, so you certainly don't have to memorize that, but anyway, good. Okay, I need to solve for b squared. Since it's a positive 25, how do I move it to the, subtract it? So we'll subtract it to the other side. B squared is equal to 169. 169 minus 25 is going to be 144. Again, I've got b squared, which is not what I asked you to solve for, so you will simply take a square root of both sides, right, because you need to solve for b, and since it's squared, square root will, right, as long as the index and the power are the same, cancel each other out. So b is equal to, and again, not one of the ones on the list, but hopefully you know the square root of 144 is 12. And so I found the length of the other side right here. That guy is 12 units long. 12 units long. Okay, so that's Pythagorean Theorem, the distance formula. Let's go ahead and take a look at the distance formula. What I've got for you right here on the distance formula, you should be familiar with the distance formula, but with the distance formula, what you're going to be doing is you're going to be finding the distance between any 2 points, all right? And we're going to call those points x1, y1, x2, y2. Now, when it comes to the distance formula, I like, just to help me keep things straight, on a coordinate plane, I will always make the point that is farthest to the left, x1, y1, and the point then that is to the right, x2, y2. And again, that's just for me. If I do it the same way every time, less likely to make a mistake. You don't have to do that. You'll still get the same answer if you make the point to the right, x1, y1, and the point to the left, x2, y2. That's kind of the beauty of the distance formula. You'll get the same answer. But again, just because that's the way I was taught to do it and the way I've always done it, that's the way that I'm going to do it here. So here's what we've got. Find DE for D equals -6 and 2, and E is at the point 1, 5. Again, these are points on a coordinate plane. I certainly could graph them if you wanted to. In fact, oh shoot, hold on, that's my highlighter. Yuck. There we go. -6, 2, let's say that is right over here. There's that point D, and 1, 5, 1, and 5 would be like maybe right up over here somewhere. Yeah, maybe like right about there. There's E, right? And so the point farthest to the left is D because it's at a -6, so -6 and then up 2. E is at +1 and then up 5, so the left point, the right point. So here's what I would do then. I would make, again, if you're doing it my way, I would make this x1, x1, y1, and then x2, y2. Again, if you switch those, you'll still get the same answer that I get. It'll work out. But this is just the way that I always do it. Point farthest to the left, x1, y1, point farthest to the right, x2, y2. Okay, at this point, guys, once again, it is plug and chug. Don't fat finger something on your calculator. You've been given all the information that you need. Plug it into the distance formula, which you should know. And yes, the Pythagorean Theorem, the distance formula, the midpoint formula, those are formulas you need to know. I will not give you those on a formula sheet, on a test or a quiz. Those are formulas that we use so often and you have seen before. They're ones that you need to know. So the distance formula, the Pythagorean Theorem, and the midpoint formula, which we'll get on the next page, you should already. If you don't, you'll need to know those formulas. And we'll get plenty of practice with them if you haven't already memorized them. Okay, so here we go. It is plug and chug. Let's go ahead and do that. So I've got the distance is equal to, okay, so I'm going to have, let's see, it's x2, which for me is a 1 minus a -6. Careful of your signs. And then that'll be plus y2, which for me is a 5 minus y1, which for me is a 2. And that's take the square root of all of that. So D is equal to, here we go, negative of a negative, add a line, change the sign, right? When you're subtracting a negative number, right, you're actually going to be adding those guys together. So that's going to be 7 plus 5 minus 2 is 3, and I will take the square root of that, right? And that's really simple to do. So D, 7 plus 3 is 10, so D is equal to the square root of 10. Square root of 10. Okay, now a quick note about radicals, and we're going to be doing this much more throughout the class, so I'll be reminding you of this as we go, but please be very, very careful. I will always ask you for exact answers in this class, which means fractions are perfectly acceptable, and when it comes to radicals, you will leave your answer in radical form if it isn't a perfect square root. So please notice on my list of perfect square roots, 10 is not on there. Here's what that means. If you were to do the square root of 10 on your calculator, which you certainly could, you will get an irrational number, a non-repeating decimal, simply meaning you have a decimal point and then you have numbers, decimal points that go to infinity. It is a irrational number, a non-repeating decimal. It just goes and goes and goes and goes and goes. Which means if I ask you for an exact answer and you turn this into a decimal, you will then be answering that problem for the rest of your life because you will never finish writing out the decimal places. And I've asked you for an exact answer, so you need to keep going. What you guys would do if you turned it into a decimal so that you're not doing the same problem for the rest of your life, you're going to round that number. But rounding means that you've now approximated the number. It's no longer exact. You had to round the number. And I've asked you for an exact answer. So when I ask you for exact answers, decimals are not acceptable. You will leave it as a radical. Do not give me decimals. I won't do it to you. Please don't do it to me. I hate those irrational numbers. I want an exact answer. Get comfortable with having radicals in your answer. It will happen and it is okay. It is perfectly okay. Now, if I ask you to give me a decimal, great, fine. And in that case, I'll tell you what place I want you to round to. It'll almost always be the thousands place. Round to 3 decimal points, okay? But, so, quick note then here about this. If I ask you to simplify a radical, if I ask you to simplify the square roots of 10, that does not mean give me a decimal. That doesn't mean give me a decimal, all right? Simplifying and decimal, please do not think that those are the same. what simplifying means is sorry, I don't want to do that one, not that one. Simplifying means pulling out all perfect squares. Let me do this one as our example. If I give you the square root of 8, all right? The square root of 8 is not a perfect square. It is not on my list of perfect squares, meaning if you take the square root of 8, you will get a non-repeating decimal. It's an irrational number, okay? But square root of 8 is not simplified. And here's the reason why. The square root of 8 can be written as 4 times 2, right? Square root of 8 is the same as the square root of 4 times 2. Why? Because 4 times 2 is 8. I haven't changed anything. I've just rewritten it. The square root of 8 is equal to the square root of 4 times 2, because 4 times 2 is 8. But 4 is one of my perfect squares, right? So I could do the square root of 4 times the square root of 2, but the square root of 4 is 2. So this is 2 square roots of 2. Here's the idea, guys. This and this are equal. They mean the same thing. The square root of 8 is equal to 2 square roots of 2. But this is unsimplified. This is simplified, meaning I have pulled out all the perfect squares if there are any. And again, you could check this if you wanted to. If you plug this into your calculator, the square root of 8, rounding to 2 decimal places, is 2.83. Put 2 times the square root of 2 into your calculator and you get 2.83, right? These are equal. They're equivalent, but unsimplified, simplified. Yes. I am going to ask you in this class to simplify a radical if you can. Simplify does not mean give me a decimal. I don't want those decimals. Not what I want. What I do want you to do is, if you can, pull out any perfect squares, if there are any. So we go back to the square root of 10. Can it be simplified? No. There's no way to split up 10 into factors where one of those factors is a perfect square, right? 10 can be rewritten as 5 times 2. But neither 5 nor 2 are a perfect square. They're not on my list. So the square root of 10 is simplified. There aren't any perfect squares that I could pull out, all right? So when I say simplify, that's what I mean. If I give you a radical, all right, and it's not a perfect square, check to see if there are perfect squares that can be pulled out of it, that can be factored out of it. That's what we mean by simplify. Not give me a decimal. That is not simplifying. In fact, giving me a decimal is approximating, and I will never ask you to approximate. Simplify. Pull out perfect squares if there are any, okay? All right, here's what we've got. Given u is between t and v, find the missing measure. Guys, these are just going to be a little bit more of the segment addition postulate. Let's go ahead and draw a real quick picture here. U is between t and v. So here is t, here is v. Draw a line between those guys, and u is going to be between them. There is u. Here's what I tell you. I tell you that tu is 4. I tell you that tv is 11. I want you to find uv. Well, here's what you know for this one. You know that tu plus uv is equal to tv, and plug in what you know. Tu, well, that's 4, plus uv, I don't know. That's what I've asked you to find, is all equal to 11. How do I solve for uv? Well, subtract the 4 to the other side, and 11 minus 4 would be 7. So uv is 7. All right, the segment addition postulate. I draw myself a real quick picture. I can easily make sense of that guy. Here, let's do it again. ut, 3.5. uv, 6.2. I want you to find tv. Well, again, here we go. I've got ut plus vu is equal to tv, right? That's my segment addition postulate. Plug in what I know. ut, well, that's 3.5. VU, well, that's 6.2. Find TV. Well, all I got to do is add them together. 3.5 plus 6.2 would be 9.7. Again, you can use your calculator to do that if you need to. Just don't fat finger something on your calculator and you should be all set. This one goes with this guy right there. And then I've got this one. VT is 5x. UV is 4x minus 1. TU is 2x minus 1. I want you to find the distance TU. Okay, so here we go. Slide up here a little bit so I can still see my picture. Here's what I know. I know that TU plus UV is equal to TV. That's my segment addition postulate. This segment plus this segment is equal to the entire length. Plug and chug. TU, 2x minus 1, 2x minus 1 plus UV. UV, 4x minus 1, 4x minus 1 is equal to TV. There it is, TV, VT, whatever, same thing, segments, you can go either direction, is equal to 5x. Again, guys, normally in algebra, you would have been given this and asked to solve. Here in geometry, I give you a description. You can draw yourself a picture. I would encourage you to draw pictures, but based on a postulate, the segment addition postulate, that allows you to take the information you were given and get yourself to the algebra problem that we can then solve. Combine like terms, 2x, 4x, that'll be 6x. -1 will be a minus 2, that's all equal to 5x. I need to get the x's together on the same side. I will subtract 5x, so 6x minus 5x minus 2 is equal to, since I subtracted the 5x, I'm left with 0 over there, right? I had 5x, I subtracted it, 5x minus 5x, nothing. Zipco, nada, bupkis, whatever you want to call it, 0. Nil, nothing. You got nothing left over there, 0. 6x minus 5x, well, that's going to be an x. Add the 2 to the other side. Careful, careful, careful. I know you've got algebra brain going on, algebra brain. You're thinking, oh, I've solved for x, I got it. Not what I asked you to do. I asked you to find TU, right? Read the directions carefully. TU is equal to 2x minus 1. Plug it in. 2 times 2 minus 1 is 4 minus 1. So TU is equal to 3. There's your answer. Again, please read the directions carefully. Don't get algebra brain. We've got to get rid of that algebra brain once you solve for x. That might not be your answer. It could be your answer, but in this case, it wasn't. And that's the second time we've seen that. So just be really careful with those. And again, the segment addition postulate. You need the postulate in order to take the information you were given to help you answer the question that you were asked to answer. All right, guys, head on over to the next page of notes. We'll take a look at the midpoint formula. I'll meet you guys there.